Okay, so on page 10, let's read. Company produces 1 kilogram packets of sugar. Quality control check found that the weight of the particles normal distributed, the mean, which is mu, 0.995, the standard deviation, which is sigma, 0.03. The company policy is to reject any packet with a weight outside 2 standard deviations from the mean. So basically we're going to reject if we are a z-score of less than -2 and reject if we're a z-score of more than 2. So what's the smallest weight allowed by the company? Well, that would represent the z-score of -2. Okay. So if we sub into the formula z equal x minus mu over sigma, okay, I'll sub in straight away. 0.03 timesing, that'll be -0.06. So it's going to be 0.995 minus 0.06, which equals to, I got an answer of 0.0935 kilograms. That is the, oh, whoops, ignore that 0.935 kilograms. Hold on, that's not right. Oh yeah, no, it's right. It'll be 935, yes, because that's a 0 there. Okay, so that's the smallest packet that's allowed, so anything less than that, they're going to reject. And also the largest weight allowed is B, so outside 2 standard deviations from the mean, that means a z-score, the largest would be a z-score of 2. And repeat the same calculation, but just use 2 instead, okay? So that would be 0.995 plus 0.060. Okay, so the largest will be 1.055. Okay. See what percentage of packets will be rejected. Okay, so a reminder that from -2 to 2, that's 95% there by the empirical rule. So we're rejected if we're outside that. So you would do 100% minus. So rejected if z is less than -2 plus if z is more than 2. Which will just be 100% minus that 95%, which is 5%. So 5% of the packets will be rejected. All right, moving along. These next couple of examples come from NES's topic guidance as exemplar questions. So this one here, find the probability that a person selected at random from a pool of people that took a test. The mean of the test was 100, standard deviation was 15. We'll have a score between 100 and 120, of at least 120, of greater than 120. Okay, so the mean is 100, the standard deviation is 15. Convince yourself the z-score of 100 is going to be 0, right? Because you're right on the mean. Your 0 standard deviations above the mean. Okay, if you want to go the long way, for a score, you could write the formula. Just substitute in 100 minus 100 over 15, you get a z-score of 0. Okay, we also need to work out the z-score for a score of 120. So that'll be 120 minus the mean of 100 over 15. That's not a whole number, so hence why they've got the table there. If you put that in your calculator, you get 1.33 repeater. Okay, this table has one decimal place. So we'll do the best that we can do based on this. So the first question, we're after the probability of a score being between 100 and 120. That will be equal to a Z score between 0 and 1.33, ... Okay, and if you're between 2, remember you can do that as the probability that Z is less than 1.33, ... minus the probability that Z is less than 0. Okay, so probability that you're less than 0, that's just going to be a 50%, or 0.5. The 1.33. 1.3 is there. So it's 0.9032. If you look at the sheet that you've got that's 2 decimal places, you might be able to get it more accurate with 1.33. It's about 0.91. Okay, so we're a bit above this number, and we're below this guy, but we're above this guy. It works out to be about 0.91. Okay, so you can use your table with 2 decimal places to get it more accurate there. We're using the 1.33. Okay, so rounding that, so it's going to be 0.41, which is 41%. Okay, does it say, it says probability, you can give it as a percentage or a decimal, doesn't matter. So 41% is my answer for A. Okay, B. B says, what's the probability of getting a score of at least 120? So that would be probability of score greater than or equal to 120. All right, so remember the 120 Z score is 1.33. A repeater. So because that's greater than, change it to less than by doing 1 minus. Okay, and then the value there is 0.91. We worked that out in part A. So that's going to be 9% of people get it. A score of at least 120. C says greater than 120. All right, reminder that this is continuous data. Okay, this is a continuous data topic, so if you've got greater than 120, that'll just be the same as greater than or equal to 120, so the answer is still just going to be 9%. Okay. The only case when you would think differently is if they tell you that you can only have discrete values, okay? So if they said that you can only get discrete values in this test, so not possible to get 120.1 or whatever, you would change that to 121, work out the Z score for 121. Okay, but they haven't told us that information. So a reminder that basically if you've got a greater than and greater than equal to for continuous, you can essentially treat that as the same thing for continuous data. Same for continuous. Okay. Let's do one more. Another NESA question. The lifetime of a particular make of light bulb, normally distributed. The mean is 1,020 hours. The standard deviation is 85 hours. Find the probability that a light of the same make, chosen at random, has a lifetime between this and this hours. Okay, so let's work out the Z scores that represent that. So a score of 1,003 and a score of 1,088. Let's work out the Z scores. So x minus mu over sigma, x minus mu over sigma. Sub in. Sigma's 85. All right, you should have got, that's a Z score of negative 0.2 and the other one's z-score of 0.8. So we want to work out the probability of being a z-score between negative 0.2 and 0.8. And that's going to be probability of z-score being less than 0.8 minus probability of z-score being less than negative 0.2. Okay, because the table only gives us positive z-scores, we're going to need to use some symmetry to work out the negative guy. So if you've got the 0, there's negative 0.2. Convince yourself that that area there is the same as the area above 0.2. Okay, so let's change that to being z being greater than 0.2. And then the table tells us less than, so we've got to do a 1 minus p z less than or equal to 0.2. Okay, let's find the values for 0.8 and 0.2. 0.8 is here, 0.2 is here. Okay, so we just need to sub in those values. So that's 0.7881 minus bracket 1 minus 0.5793. Okay, and when you put that in your calculator, you get 0.3674, which is 37% to the nearest percent. Okay, the question didn't tell me to round, but I'm going to round it to the nearest percent.